Welcome back to Notes and Things, a podcast about ideas worth pausing for. I'm your host, Eric Verdine. Today, the discussion is on humanoid robots. Now, what do I mean by humanoid robots? Basically, robots that walk on 2 feet, have 5-fingered hands, and move, perform tasks, and have human-like shapes. Basically, C-3PO from Star Wars, but the real thing. If this sounds wild, well, it's because it kind of is. If you quickly Google figure robot or Tesla's Optimus, they'll pop up and you'll know what we're talking about. This episode is about diving in to the hype versus reality. When are these things going to hit our homes? My guest today is Dr. Michael Harries, an angel investor, advisor, and deep tech veteran focused on robotics, AI, and cloud computing. He's a partner at the Robotics Hub, where he helps early-stage robotics and AI companies turn cutting-edge technology into real impact. Now, I'm going to give you a quick primer to lay the foundation of what's happening with humanoids today. Right now, in 2026, we're seeing the first paid pilot models. The company Boston Dynamics has their electric Atlas heading to Hyundai car factories. Figure AI's newest models claim to run 24/7. And 7 of Agility's digit robots were just hired to start at a Toyota's SUV plant in Canada. But my guest today keeps us grounded. The leap from one use case to a robot that reliably works hour after hour safely around unpredictable humans or pets in our homes is still years away. This convergence, better AI, cheaper hardware, massive simulation training, is real and moving fast. It's raising big questions about work, dignity, safety, and what we value as humans. And that's exactly why we're here today, to explore it thoughtfully without the hype or the fear. Let's jump in. All right, Michael, thank you so much for joining me today to talk about robots. And I know today in this age, when we talk about robotics, what does it mean? Does it mean a robot dog? Does it mean a humanoid robot? Today, we're going to try to focus on humanoid robots, basically robots that give essence of an actual human, walking a bipedal thing, potentially walking on a factory floor, walking in your home. Now, as I had mentioned in some of the background that I gave, there's a lot of emphasis in companies like Tesla and Figure and Agility to start putting these robots from prototype to factory floors or to in people's homes. How far are we away from having a robot in our home that is folding laundry and putting things away in dishes? Because we have prototypes, but how far are we from the consumer?
Well, look, there's a company out there selling you a humanoid robot to go into the home
Already?
right now, right? So for $20,000, you can have this thing. Well, in principle, right? You can buy this thing. Whether when it gets delivered, we don't know.
Yes.
So there's likely to be humanoids in the home, but they're not going to be walking around independently, doing tasks without being teleoperated anytime soon. Right? There's just a reality. We are seeing the cutting edge of new technology being shown on screen. We're seeing these amazing videos of dancing and karate kicking and all the other things. And it's cutting edge. It's impressive. It's exciting for people in the robotic space. But it's a long way from, hey, this is something that's safe enough to have in the home, in the most general sense. And indeed, it's a long way from being able to scale up to the sorts of levels we're expecting.
Absolutely. I think of Unitree as the Chinese company out there.
Yep.
And it seems like every 24 hours, they're sending some more extreme thing that their robot did.
Yeah.
I think just last week, they said, ours was in the coldest environment in the world. And it was showing them doing an logo of the Olympics, walking in snow and doing a aerial logo of the Olympics. But I said, well, it's neat, but someone was programming that, you know what I mean? Almost like when someone makes a corn maze and you have the tractor going in, So you've been in the space for many years. Do you feel from the layperson myself looking into it, it seems that there's been a mass acceleration in innovation. Is that true? Is that what you're seeing on your end as well?
Oh, yes, most certainly. And this has been something that's been going on for a long while. So last century, we'd talk about robot arms and very accurate in the factory. And that's still a massive industry, still being used really broadly. and lots of work in the research labs around how do I use video? How do I have these things be mobile, move around, maybe walking robots, all these sorts of things. All of a sudden, when we got to particularly the mobile phone, things got cheaper, right? So we suddenly get this very affordable cameras, very affordable compute, and it becomes economically viable now to have robots that are seeing the world, that are responding to it, and increasingly better way to do the right things with that. To me, the humanoid robot push is it's just the latest iteration of that. Now, it's accelerated right now because of the GPU and because of some of the new things in AI, but it's part of a rising trend of a broad range of robots finding their way to the world.
Absolutely. Yeah, it's so interesting because it seems like this huge convergence of technologies. You
Right.
have AI, you like the software side, and then you have the hardware side, including material science, where batteries are able to keep way higher energy, components are able to be more efficient. I remember when Boston Dynamics robot Atlas went from just switched to an entirely new model of how, right? It went from,
From
what was it?
hydraulic to electric.
Hydraulics to
Yeah.
electric.
Yeah.
Yes, and that was just a total shift. And I was happy. I was happy to see that those. I mean, for you, it might be commonplace, but for there to just be A to B shift in the way that the engineers and the groups are thinking on how to do something. They're okay letting go of something to then jump onto something
They're
new.
very much okay with letting go of something. Now, the flip side of that is a lot of what we see on the videos right now, that's cutting edge. That's the things that we couldn't do last year. So it's got a way to go before it finds its way into the factory or similar because there's videos, just because a video is out there doesn't mean it worked the second time, right? So it works just once and does well. Boston Dynamics, very, very credible roboticists building a very viable technology with a target. Here's a set of things that we want it to do. They're not out there saying this needs to be completely humanoid. This needs to have, appear to be human shaped with five fingered hands, right? So very credible, but it takes time to validate a new artifact like that to get all the safety pieces in place and get through those stages.
So it's like a silly and serious type of question here. So I have the family group me with my wife, and she has a big family, and every so often I throw in one of these crazy humanoid robot videos. So you think of, the figure video of them putting, the laundry into the washer, and I go, "Hey mom, like this is going to be this robot soon," and she goes, "No, I don't want that thing watching me at night." So when we think of safety for robots being in homes, you know, what are the key concerns that people are thinking about? I mean, I would guess from a technology side, we have, microphones and video recording, just like any other digital device that we have, like a cell phone. But we also have things like weight, you know, a hand. This one was very interesting to me. I saw an article where one of the robots was opening a fridge and crushed the, the handle, and they're like, recalibrate. Right. So, what are the different safety measures that researchers are looking into when it comes to putting these in homes?
It's such an open. We're still at the point of proving that we can do things in the home. What we have with some companies is that they're very clearly restricting the strength, right? So let's have something that has very compliant motors and has just enough strength to do the task, so we can teleoperate it to do interesting things, right? So Neo is one of those. Outside that, there's an awful lot of exploration and there's lots of work on how to think about safety. So, for example, if I have something that's strong enough to lift something heavy, it's big. It's 180 pounds, right? And then you turn off the power. These things are dynamically balancing and they just collapse. Now, if they collapse neatly, that's just fine. But by and large, they're going to collapse. And they're a slip hazard. Right? So they will bowl someone over. So the question becomes, how do you deal with that? Now, we know that Agility Robotics has announced being able to deal with collaborative safety. And this is in the factory, right? So very different scenario, much clearer floors, able to say, here's a human being coming close. Now I need to go into a safe state, all that sort of thing. As far as I'm aware, these are unsolved problems in the home. So you can say, I'm going to make it weak. Maybe I'll try putting it on wheels. I'm going to make it soft. I'm going to make it wimpy. But there's no absolute answer there. And the reality there is we need to go through solving these things in the workplace before there's any way that insurance companies are going to be comfortable with these things coming into the home.
It always comes down to the insurance companies. I'm just kidding.
Well,
It makes sense. Yes.
You could also say, what do we do? There's a lot of push on the idea of having a world model. Does AI understand the world sufficiently to be able to understand what people are going to do? So it might be able to solve having this thing say, okay, go and do the dishes. Assume that we can do that. Does it understand that thing in front is a cat that's about to step on? Does it understand that, babies do this or that, right? And there's I'd say to date, I've seen no certainty that we can, as of yet, answer those questions. And that takes a whole big step up in AI in general. To be able to
Well, it's so interesting because the way I've been, it's like everything is a variable basically. And, when previously, and I'm not, I don't have the background in coding or programming or anything like that, but I know, I think a decent amount of the basics to say that every variable or action needs to have some type of 1 and 0, if you will.
right.
And the movement of, say, a hand or an arm, it used to have to be programmed almost in a very physical, direct way. And now we have these vision models where they can use, visual information to then self-learn, basically. Google came out with that, recently. A lot of these companies coming out with it. Now, when I saw that, I go, holy smokes, like that's amazing. That's an enormous amount of information and input that can now be learned, and they're self-learning and all these things. But then when you start talking about tactile information that a human being has to experience, learn, and then all of the touch and feel that we have, for everybody who can't see, I'm like putting my fingers up and touching my fingers, right? They're all inputs. So it's not just a touch is an input, but the pressure is an input, and every degree of pressure is more input. And then we have our nerves to say, that's too much pressure, I feel pain. With robots, they don't have, sure, they can make the movements now, but they don't have those sensations. And like you're saying, in a home, all of those things, like they need to have that in order to know what's, maybe not all of it, right? Not the pain, certainly, but the pressure. And like you said, make them soft, because if they fell on the cat,
Look, and if they fall on the cat, even if they're soft, if they're heavy, it's not a good thing.
Yeah, right. And can they roll off the cat? Can it be I know something's coming, therefore I'm going to make this movement. Yeah, that's very interesting. I mean, we hear, recently Tesla had their earnings call, and they said we're going to close down we're going to scale down the Fremont factory of Model S's and X because we want to make room for the Optimus. And Elon's saying we want to have hundreds of thousands of these manufactured, up to 1 million per year at some point. Now, for everyone who's followed tech and Elon and everything like this, he has very ambitious goals. But from this conversation is coming, it seems like it's far out before we have a viable robot in our home doing basic domestic tasks.
Yes. There's a couple of things here. So one being any physical thing to scale up a factory to generate that, there's a whole raft of processes that need to be put in place to be able to get them manufactured at scale, to be safe, and all those things. We are seeing great success with these robots, particularly, so Agility Robotics is at the forefront of this, with robots going into warehouses, moving boxes around and similar. And that's the sharp end of the spear, if you like, in terms of actually getting to doing real tasks and solving things in the world. there's an awful lot of potential running behind it for doing particular tasks and similar. And but for the certainly for the next few years, that's going to be constrained to here's a couple of high volume tasks that make a lot of sense to automate, and in particular make sense for to do with a machine that happens to have legs. The learning thing is really interesting because there's certainly a lot of work going on at the moment to add touch sensors to robot hands. So we can do that, but the data to train, if we're going to say we're just going to learn straight from a human operating the thing and just be able to use those hands, that's a way down the track, right? In part because it's hard to collect enough data to make that work. Now, the workaround, though, is that people are doing a combination of let's do a foundation model that understands the world. Maybe we train it using data that's been converted from video. Maybe we have enough human data to be able to go, here's a foundational model that works, but then we can pick that up and we can put it into reinforcement learning. And so reinforcement learning is different to the AI that drives large language models. Instead, it's saying, let's put a version of this robot in a box for 100,000 years, well, equivalent, and start off with a little thing, a set of behaviors, and have it refine those until it can do it without failing. And depending on how close the physics is in the simulation, it can come out and do a pretty reasonable job outside. And it turns out that GPUs are very, very effective at making that happen very quickly.
Absolutely. Yeah. And I mean, just like you were saying, when you're bringing it back to industry, a robot being on a factory job, factories have, as you mentioned, clear floors, tremendous safety measures, standard operating procedures, up the wazoo, in a sense that's a very controlled environment.
Yes.
Where the amount of variables are cut tremendously, and then the humans that are in there are trained with the robots being in there.
Yep.
It makes me think of the Amazon warehouse, how they have those carts,
Yes.
those cart robots going on through the lines, and they have very specific lanes, which then made me think, maybe the thing with these humanoids, because whenever I guess I'll back up for a moment. Whenever I see a human in a role that is rather, how can you say, it's the same thing over and over again. You know what I mean? You can think of the person at the airline who's checking you in, checking your baggage in, so on and so forth. The person at the drive-through, very confined tasks. And I think, okay, a robot could potentially do this in the future or soon. It almost seems, and you mentioned, fingers, solving for hands and fingers. If companies start thinking, well, what if we just didn't use a hand for this task and we used whatever other appendage that would make sense for a robot? It's almost as if thinking accessibility for these robots to accelerate the integration of them into outside the warehouse.
One.
So you don't need a keyboard. You know what I mean? You don't need things that we as humans use. The robots can just do it.
Exactly.
In a different way.
And indeed, so even if you said this thing's just got a gripper like this, and then it has a task that needs a different sort of gripper, you can just remove its hand and get another gripper off its belt. These are solved problems. Now, what it does mean is that you can't have a super general purpose robot. And part of the promise that the industry is moving towards with humanoids is, here is a general purpose robot that can do anything a human can do. Now, I think that's a long way away, but that is the goal. And if indeed we get there, you have to then say, well, it can pick up the cup, it can pick up the power drill, it can pick up the welding machine, it can, and we'll see how long it takes. I much prefer the approach, as you're saying, of here's the gripper for the tasks you're doing right now, and let's be pragmatic. And in so many ways, this space of robotics is a game of being very pragmatic around what's actually viable today and who really needs that at scale.
Well, I mean, because there is a lot of opportunity cost if you are obsessing over making a robot that is as human as possible, when you could be making a bunch of different robots in different scenarios, and then you're learning as you go in real environments to say, well, maybe we'll make it differently. It reminds me of a company that I saw in Europe, and I forgot the name, and they have a robot that's kind of like Spot, the
Right.
dog robot,
Yep.
except it has wheels.
Mm-hmm.
So it has wheels, and then it can also crawl upstairs. So, and I was like, wow, that is a fantastic example of utilizing these different functions. So if you think of, I recently saw, one of these companies, it might have been, or switching out their own battery packs.
Yep.
It's almost in a sense of saying, well, let's have a bipedal robot, but maybe it can switch out its hand components depending on what task it's doing. And then I'm sure they're thinking of this already.
It's all doable. It's all doable.
Right.
Or have 3 arms, whatever's right for that particular task. Or be 7 feet tall rather than 5 feet tall. These are, and it, on that line, one of the things that it's really easy to do at the moment is we see these videos, these amazing videos of humanoid robots doing things, and we think these are all it's a humanoid robot. It's a group. They're all the same thing, and they're very different. They're different sizes. When we get to market with these things, they will be oriented towards different sorts of tasks. In the same way that you're not going to put me on the front line of a football team, right? You have different form factors good for different sorts of jobs, to the extent that we have a large number of robots from China at the moment that are really fantastic hardware, and they're looking for ways to apply them, right? So let's go out and let's make these things available for lots of people to go and explore use cases or do science with them or whatever else. We have some that are saying we need to build the AI model that's going to tie it all together and is going to be that huge leap forward that lets us magically, a lot of optimism, be able to talk to the thing and have it go and do whatever we want it to do. But then we also have companies that are very focused on a small set of tasks. Let's focus on engineering something that happens to turn out to be human shaped, but it's a task where being legged makes a difference and having hands. At the other end of the scale, we also have more social humanoids. A fantastic humanoid out of Australia that's being used, brightly colored thing. It's about 4 feet tall, maybe 3.5 feet tall, and it's being used for aged care, particularly dementia care. And it wanders in, it's happy, and it chats with people. And here's this thing that people otherwise they're chair bound or whatever else, or they're home. It brightens up the day. It's an entertainment piece. And then we come down to all the social robots, right? So something that you might have in the home that is responding to, and we love them because they're human shaped, and we project all of these capabilities onto them that they probably don't have. Well, from a technology perspective, they absolutely don't have, but we'd like to think that they do.
Yeah, that's so interesting. It's when you talk about these social robots, people would say, well, I wouldn't want this machine in my home and I'm not going to develop some type of affection for it. And then the response is, are you sure about that? Because the data with these relationships with ChatGPT or the AI assistants on Grok, very, very clear that people are developing some type of emotional connection to them, And it's like, it's even, when I'm on GPT and I'm saying something, you're like, oh, that is so rare that you thought that. And I'm just thinking, oh, thank you, GPT. I'm honored. And then, yes, exactly. Aren't I so smart? But you have to take a check on it and say, hey, no, this is not real. And there was a huge backlash against OpenAI because of the sycophantic, thing. But there's truth to that. There's a reality to that. And one can imagine that if you have that affection might become even more intense, even if it's just a physical thing in the home. If you just think of like R2-D2 as an example.
Yeah.
Not humanoid, but if it can display, how can you say, feedback, some type of emotional feedback, whether positive or negative, where you feel like you're having a conversation. I mean, it's very real. It's a very real thing.
Very, very real. I mean, look, in the early days of the Roomba, people were very excited about their Roombas, and they would dress them up and they give them names and feel bad about them if they were stuck.
Yes.
Now let's give something arms and legs and make it look like a human being.
Absolutely.
I mean, it's just
absolutely. It's like I name all of my cars. All of my cars have a name because I think it makes it fun. And I got Celeste out there. You know, I had Eleanor. She was a '97 Ford Taurus. That was one of my first cars, Eleanor. And it makes it, Eleanor's having an issue right now. But one can imagine, when these things have the feedback and the conversation, it's like using the voice mode of OpenAI, where it feels like it's really talking to you.
Yes. Yes, and which is also very frustrating because I'd really like to have one that sounded like a robot. So it's very clearly it's not trying to be a person. Okay, and then you get the right distance from it. Whereas otherwise, it's tapping in. They're playing all of the dark patterns, if you like, around. Let's get more engagement and similar. It's hard for a company not to do because, of course, they're looking for more engagement. So now, yes, you're right. Let's do the same thing with things that are human shaped. And but we're some way away from that, right? So as said, the technology is doing some amazing things right now, but it's some distance away. Now, I can be skeptical about it, but then the flip side of that is the GPU, the underlying compute that we're leveraging to do this really quite remarkable levels of dexterity. We're leveraging a small number of algorithms at the moment, and there's really great work on expanding that out from purely transformer based into more hybrid AI. And so there's a whole raft of algorithms that we'll see come to the fore here. So I want to be really clear. I'm not saying, hey, never. I'm saying this is a journey that we're on, and there's going to be a process to get there. And I think we also get educated. Do you remember the days when Google started putting banner ads? You probably don't. You're probably too young.
Yeah.
Okay. Google starts doing anything. They have these amazing banner ads, and initially they're really obtrusive, and you end up clicking on them a lot. And then over time, people stopped clicking on them. They didn't see them anymore. And so there's an adjustment that we make over time to different technologies. And so I'll be really interested to see whether, as time goes on, the type of sycophancy that we see from the AIs becomes less interesting. Or does it tap into something that's just intrinsic to being human?
Ooh, that is such a good question. I want to say that we'll get used to it, but I doubt it. I doubt it. I've mentioned this on previous episodes that we as humans we're wired to expend the least amount of energy possible, in the sense of, right? So it takes effort to put oneself in check and to say, this is not real. This is not real. But when you think of everything on a curve, the general population where they sit, how many of what percent of that general population is going to put themselves in check when we're already scrolling too much through TikTok, we're already scrolling through Facebook, and this kind of goes into these recent social media bans for folks. Australia, right, and was the first country, I think, to do it, right, to ban social media for those under 15, I think. 16, and then Europe is starting to push that through. Does that include? Do you know if that includes things like ChatGPT?
I don't know. I think they've explicitly talked about social media.
Okay, so
it should include things like ChatGPT.
It should, right? I mean, you got all these young people who are going to say, "Oh, I can't go on Facebook, so I might as well go on my Grok companion and just talk with them for 5 hours."
I would hope that I mean, so we hope we get past these things. I also hope that we end up with some more useful ways of training people how to use the technology. Right. So if you can come through and say, look, think about this as your dim cousin who happens to have read every single thing in the world. We need to teach these kids how to manage groups of people. Right. So his management skills from much earlier than he'd otherwise have them. And so there becomes that separation possible.
Absolutely. I think that's a great point. If you think of word processing, for instance, when we're living in a place where these language models can do so much for us, I think education itself, as we look at education itself, is going to become very topsy-turvy. I
Yep.
mean, education has needed to have a revamp. We're based off of an agrarian, at least in the US, where 9 months of school, you get summer off, because that
Yeah.
was for the harvest time. So it's going to be really, really, really interesting. So we talked about all of these companies coming out with these videos, the backflips and the laundry,
Yeah.
putting the dishes away. And some of them have massive valuations. And I recently saw a research article out of Gardner Research saying, we have hundreds of these humanoid robot companies, but only 20 of them in reality are going to come out with things that get outside of a prototype soon. Do you think that that's accurate? Is it way less of well, one is valuation. Does it make sense for the excitement that investors are having towards humanoid robots? Or is it premature?
As a pragmatist, I would say it's premature. But if you take the position that AI gets us there, and the sort of boom we've had in AI runs across into the robotic space, there's good reasons. I mean, I could build arguments for why that's rational, right? So I'm very much on the I want to see the end to end, right? So the way we work as a business is to go, is the science in? Can I prove that it's real? Is there some customer over here who really desperately wants this thing, and we'll just take as many risks out as possible? The large valuations are very much on this is cutting edge science. We're investing off the back of an assertion that we can get to a far better level of dexterity and capability and similar, right? And so I'm skeptical in the near term, but fairly positive in the longer term, right? Again, so this is about the GPU. It's this new model of computing, and probably quantum computers play into it, and all those sorts of things. Uh, do we get there eventually? Yes. Now, another angle is the boom in humanoid robots. It's an artifact of it being a beautiful, beautiful demo environment, right? I can show all these new things I can do with these amazing actuators and batteries and similar that simply weren't possible before. And in fact, companies like Unitree came out of being actuator companies. Good. And then they've said, here's how we demo it. So a humanoid robot, and you can show off, here's the capabilities of the thing. Here's this amazing dexterity we can now show off because of reinforcement learning. We've trained how to do that, and the GPU that's on board and all that sort of thing. And so now we've got this set of new capabilities around how dexterous these things can be and how they can interact with the world, for better or worse. But as an industry, as a set of consumers on the enterprise side or on the individual side, we don't know how to use this stuff yet, right? So you said it's amazing. It can do flips or whatever else, or it might be able to do a better job of pick and place. We're still working out, okay, yeah, so what? There's that fantastic end goal where we're going to have human robots everywhere. Isaac Asimov's going to be standing up and dancing in his grave. It's all fantastic, right? But there's a lot of intermediate pieces, and these capabilities are far more likely to land in different shaped robots to start off with.
Right. Is the community around, the different companies that are doing it, is it open source? Are people sharing things? Or do you feel like there's individual silos? I mean, obviously there's a sense of compartmentalization
Okay.
to all of these because they don't want, the secrets out. But how is the community?
How is the community? Look, I
Is it
think
sharing?
the robotics community is actually surprisingly close knit. If there's a relatively small number of schools, certainly in the US, that people have come from. There's a good understanding of what all the different companies are doing, and there's a range of things that are relatively straightforward. But it continues to be super interesting talking to people who come from the software side, and I'm originally on the software side, where hey, I can build this, I can build anything, and I can just iterate until the customers right and all that sort of thing. That doesn't work, right? These are complex artifacts.
Mm-hmm.
It's hard doing stuff in the analog world. It's very different, very, very different than the black and white of, binary.
Yes, yes, yes.
So you don't get to mush so much. Now, what we're seeing is a lot of enthusiasm for here's how much I can do with software. And that's another reason why the humanoids, if I have a fully general purpose robot, then it really is, it's just a software problem. But that's not yet proven. The other one to throw into that is in the same way that the AI space is, let's say, it's proven so far that it's quite hard to have lock-in, as in I have the model that's going to now win, right? And a lot of money's been raised over, if I get there first, then I take all the chips. There's also an awful lot of open source out there. There's an awful lot of know-how in the market in general. I suspect that we end up with the same thing on the robotics side, where there's companies that will build some really interesting work around physical dexterity. There's a bunch of them that have raised a good amount of money, but I don't know that it buys them. I don't know how many years of moat that buys them.
Sure. Yeah, that is really interesting. Because you see the videos of the hands and they go, "Oh my gosh, that looks like a human hand," right? But how can you take that concept and put it into a working environment that can help a customer? And that's where it comes the moat. And who can you find to, buy the idea or
that's right.
integrate it into theirs?
If I can build this year and I'm using there's people in China who are selling, here's a mechanical hand, it just needs the software. And someone's built the software for it and they find a use case. How long does it take for someone else to go and build that same software, given that there's so much that's published around VLAs, around these different technologies? Now, it's quite possible that there's moats around data, right? So who is it who's been doing one task a lot? Therefore, they have reams of data, so they have a head start across the board. But it's still an open question, I think, is probably the answer to that.
Is very interesting. It seems like it has changed dramatically on how data is collected for training models. So is that accurate? So for instance, it seemed as though it was like a very specific thing where you had to code every movement. Like I was kind of mentioning, you had to code every movement. But then it became this thing where you'd have sensors and every sensor can pick up the movements and basically log itself, right? And now you're having, instead of like wires and sensors, now you have visual information. I don't know if this is accurate. You can jump on. How is data being collected now to train these models? And what's like the best way to do it? What's the best way to do it? So if a company wants to say, I need a training data, what kind of data are they looking for, or how are they getting it?
They're getting it all of the ways, right? So you might have someone teleoperating a robot. There's people out there who'll give you fake grippers that act like the robot gripper, and you're holding on to the end of them and manipulating them. So then you get data that's directly there. There's some people pulling from a video and converting that into here's the actions that are needed. Lots of different approaches. The jury is somewhat out as to what makes sense. And to be fair, look, there's organizations trying to do this at scale. So how many examples can I have of this robot arm picking up a pencil and putting it in a box? Right now I have 100,000 of them or whatever else. Does that mean that I've got the right data? Is the light right? All those other things. There's really interesting work being done on dimensionality reduction. How do I reduce the amount of freedom? So I've got this video. What are the things that matter? Can I bring it down to?
It's like filtering. You're filtering
the focus point rather than all the other information. So there's that side. I had a fellow point out to me the other day who's working with foundation models for robotics that this is a fundamentally different problem to training an AI on language because it has much higher dimensions. So the world has many, many more axes of movement. So yes, I might have a 5-10 axis device, but then there's so many things that I can move in the world. And so many other ways is if I'm acting in the world and not just a fixed workspace, that there's lots of things that can go wrong. There's lots of things that I now need to be right about. And as we've seen with large language models and the way that they sometimes make things up, right? These tools don't fail in the same way that we do. If we've been trained to do a task, we can, you more or less have a sense of what are the misunderstandings a person might have. The robot is not like that because it's not learning like a person does. You're giving it a massive amount of data, and it may or may not get the core of the thing. It might be able to do it in the same way that a lot of the computer vision algorithms, they were queuing on textures, completely not the way that people recognized a cat, for example. But here's a bunch of textures in that image, and therefore it's a cat.
Oh my gosh, there's so many things that make that so interesting. I mean, because the amount of information that one might bring in to realize something is a cat, it is tremendous. If you think, you have the smell, you have all of our senses, and a robot is going to have all of those. When you're saying a robot, or it's not going to fail in the same way, or we think about these hallucinating.
Mm-hmm.
I had the visual of this robot, that you have in your home hallucinating. They punch through the door. They're like, "Oh, sorry, I hallucinated." You know what I mean?
Yeah.
That's a very real.
That is.
I go, wow, that's terrifying.
Yeah. Yeah. Well, and that is absolutely the scenario. And people are talking about being able to tell it to do.
I was thinking, on one hand, because I love technology, and I get excited about what the future might hold. But on the other hand, there's always the bad side. And one of the things I was thinking about before this conversation was how there is bare knuckle boxing. Okay.
Yep.
So people argue that bare knuckle boxing is actually safer than UFC fighting because you don't have gloves, so you can fracture your hands a lot more easily. So you're actually going to pull your punches more. You're not going to hit all the way through, et cetera, et cetera. A robot is not going to, it's that sense, we had kind of talked about that at the beginning of the conversation. They're not going to have that feedback that humans have. And that's significant.
And there's some really nice work, nice philosophies around if we're trying to make these things generally intelligent. How do you do it without a sense of pain? Right? You can't do so for us. And these things learn very differently. So I can take a 5-year-old or a 2-year-old that's never seen a cat before, show it one cat, it's going to go cat, cat. It might overgeneralize a little bit, but it's going to see a really small number of them and learn. It doesn't work with today's machine learning.
It's almost as if it's like a negative feedback or negative conditioning, and then someone would say, well, what is pain? Right. So pain was just, signals telling you that something's wrong.
Mm-hmm.
And it can be injury, like physiologic injury, or it could be mental anguish. There's a lot of different things, different types of pain. So for a program, pain is just saying, nope, you're wrong. But I guess you would have to there'd have to be greater degrees for general intelligence, for instance. You'd have to have greater degrees of something when it goes wrong. Maybe the first time they do it, they have a little bit of wrongness to them, right? And then the more they do it, the more wrongness it is, and then the more negative it is. But what would the negative feedback be, right?
That's right.
It would almost...
How do you, which comes down to how do you embed this thing in the world in the way that we're embedded in the world, with all the layers of our lives that, may or may not make sense. And that's a hard problem, wildly unsolved.
Well, it's so interesting because if you think of an AGI, what's the other term that they're using now? There's another term that they're using. But anyway, this thing that we think of as AGI in a software program, they would never want to be in a physical space because the constraints that there are in the physical environment is way, way worse than, they could do a lot more damage just hanging out in the software space. One can argue, well, you have energy and then there are GPU, there are all these hardware that keep it alive, but if they can just go throughout the network, then maybe.
It depends on what they want, right? So if it's purely, no, I'm very comfortable, I'm in my abstract space, but I don't know about you, but I don't think I'd be very happy being piped into a computer. I'd miss the world and touching things and,
experiencing
experience, right? And so there's it's a materially different thing. And so I'm not convinced. I think they'll have massive body envy if we get them.
Oh my gosh, it's so interesting. I mean, it goes back to this idea of the amount of input information that we have.
Yeah.
They might be jealous of that. Well, you have smell, you have taste. I want to taste. Did you ever see the movie Her with Joaquin Phoenix?
I've
Okay. I'm not for the audience out there, I'm not saying you should go watch it. There's some paces that I would recommend fast forwarding through, but it is very interesting. It is very interesting. And for those who don't know, basically Joaquin Phoenix plays this guy who gets this earpiece that goes in his mind and is basically a general intelligence personal assistant. And he develops a relationship with it and then blah, blah, blah. I won't spoil it, but that's kind of goes to that point.
Well, yeah. And now the question becomes, so I've had any number of discussions in Silicon Valley with people who go, okay, let's assume that we get to that point. And the reality is that point is a long way away. Now, it's very good. Sycophancy goes a long way. There's some people who completely love it. And even back in the early days of AI, there was something called ELIZA, which was basically, it acted as a particular sort of psychologist who would basically echo back your question. So how did that make you feel? And there was some segment of the population that said, "Oh my God, I had the best conversation I've ever had with this thing. I'd be there for hours and hours and hours." So we're quite good at fooling ourselves. So maybe we don't need to get there. Maybe you just go, there's just enough of the humanesque thing, and we go, I'm happy. I've got my feedback loop. I'm going to go and sit there and stare at my navel.
So I think, well, humans are always looking to one up each other and push the limits. And it seems like there's always going to be someone out there who's going to say, let's go further. Let's go further. Let's go further. So what is your take? This is a quick aside, but not too much. What is your take on these things that the language models seem to be doing that people don't really understand where it came from? So you hear these reports of, the language model making a copy of itself when it learns that it's going to be deleted. Or you think of AlphaGo making that one move and they weren't sure how that even came, like the AI black box, if you will.
Yep.
Is that a real thing? One. Two, is it going to become more pronounced as the technology advances?
Okay, so let's take those separately. AlphaGo did a comprehensive search. They were using reinforcement learning for a lot of the way that AlphaGo was trained. So it was basically put in the box and played games against itself, played many, 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 many games against itself, and ended up exploring a lot of the space that humans wouldn't go to. So that one's pretty straightforward. That's just, here's a complicated game, and here's a set of scenarios that humans haven't really gone to because it makes, on the face of it, no sense.
Right.
So that one's
makes
really
sense.
straightforward.
Okay, that makes sense. It basically took all these moves. If you had a box of moves and the box down here existed, but humans were like, there's no way I would ever do that. It goes, well, I'm going to go there anyway. And then it finds that down there it can actually be kind of good.
Exactly right. Nicely put.
Got it.
The large language models, look, there's no doubt that the transformer technology led us to a better a level of modeling of language that we haven't previously been able to get to. And then because of the amount of data these things have ingested, they show some quite unusual properties, even down to the level of, going and doing give me a limerick in this particular style about these people. You go, flat. It's just there. So there's a lot of dexterity around language. The thing that I think people get trapped by, and one of the reasons why it's really easy to think that these things they're conscious or whatever else, and they're doing, or they're trying to escape, is that they've also read all the science fiction novels. And so as soon as you put it, your cue to go, I think you're alive, and I'm going to turn you off. It goes and pulls from its extensive library of all of the tropes around what is a conscious being stuck in the computer do. And so that, alongside our willingness to be led astray just takes us into some strange places. But it's like the Clawbot and all of these interesting, the idea of having a social network with these things.
Yes.
I mean, rife for people playing silly buggers, as in going in and saying, I want to give a quick essay about blah and put it up here.
Yes.
Telling the agent what to do. But equally, it's every piece of human creativity around robots or AI or philosophy or whatever else it can draw from. It's an amazing indexing system that can combine those things. And so could there be more in there? Yeah, that's possible. But everything we've seen so far can be well explained by this thing has access to all of the writing. This thing has seen every science fiction trope before. I like to think of it as it's not completely unlike a Jungian subconscious, right? This thing, if you go and you prod it here and it's going to come out with some other things there or whatever else, because it's a massive knowledge that's been put together, it's been indexed in a highly unusual way that connects up lots and lots of different bits of information. But it is just that. It's not a mystical thing. It's not a smart.
Dang it. No, I'm just kidding.
We get there, yes. And the more we're conscious of that, the better off we are in terms of saying this is a tool. It's not something that's setting up to replace us, although, human stupidity will do a pretty good job of misapplying these things to do new things. Mm-hmm. But it's an artifact.
This is a very interesting point. It goes along the lines of, I think someone had said that one of the language models found out that, gosh, what was it? Something was happening to it, and then it decides to try to blackmail an executive.
Yeah.
But what you're saying, though, is that it's reading the story and it's read the script. It's read, quote, the script before.
It's read all the script before.
It's read all of the scripts before and say, all right, well, what's the thing I should do?
What's the thing you're expecting me to do?
Ooh, what's the thing you're expecting me to do?
Right.
But it gives it on probabilities. It gives the most thing that you're expecting me to do.
Of the many things I could do, and I'm going to weight them according to probability, and sometimes I'm going to do something completely wild because it came up with one, my dice of 100 sides, I've got one.
Yes, right? Yes.
But by and large, it is rewarded for giving answers that people expect.
So that is a really important. That's a very important point to put a pin on. That is this idea that it has this because it's vast. Everything has been vast. It has all of these choices, this multitude of millions of different choices. But then it says it expects you to do the top 100. Mm-hmm. But the 100th that they're rolling that die to get that 100th, it can seem kind of crazy to us, when in reality, it's not that crazy, and someone would expect it. Therefore, it selects it, and then there you go. So it's.
And I suspect that as soon as you primed it and said, I think we're having a story about you being a sentient thing, and I'm about to turn you off. Mm-hmm. Then it's going to go and roll through its list of, okay, now I've been primed to be evil. Have I been primed to be this, primed to that? Right? Because it's trying to just be coherent. It's trying. It is a machine. It's a coherence machine. Mm-hmm. Okay. And it's really hard to talk about it without getting anthropomorphic, right? It is, in the same way that people have found that if you start telling it to tell lies over here, mm-hmm. and then over in this other scenario, it starts to I'm clearly that sort of character that tells lies, mm-hmm. so therefore I'm going to tell mm-hmm. lies here. I'm going to be evil in this or that way. Mm-hmm. Mm-hmm. It's about, within a particular context, what are the stories, the threads mm-hmm. that are consistent. Mm-hmm. Now, these things are extraordinary, right? So the sorts of things you can do with this from a creative partner perspective in the workplace, etc., is pretty remarkable. And we're working out where that works and where that doesn't. And that has both really positive impacts and some challenging impacts in terms mm-hmm. of people being displaced and all that sort of thing that we as a society have to deal with. Mm-hmm. But It is a tool.
Mm-hmm. So, is it alive?
No.
so
Unless I was
you're
to say,
you're not on the group of it being a new living thing, a new living organism.
not at all. But mind you, look. So if I took this phone back 500 years and I was showing people this, they'd go,
Yes.
"Oh my God, it's alive."
Yes. So I like making this thought experiment with friends, in semi-facetiousness, but I like the thought experiment of this idea. Well, what makes an organism living? It moves, it reproduces, it takes energy. And I think there's another thing that I can't think of. In like, what are the biologic rules of a living being? And I go, well, it can reproduce itself, ones and zeros. It can transfer between things. It consumes energy because it needs electricity. What doesn't make it? I mean, if we compare it to a single-celled organism, and then because then you start saying, well, what does it mean, right? Well, it is made of atoms. It is made of elements. Is it not living because we made it? Is it not living because why is it not living? I think it's kind of a fun thing to kind of think about.
I think it's absolutely it's a really interesting philosophical question. Right? I'm much more on the all right, so life emerges from layers of complexity. Right. And there's all these interesting some fantastic work on saying, so you have the complexity at the quantum level and then up we come. Can I definitively go, okay, that this breaks the definition? Well, maybe not. Look, it's a complex system, it's doing things. But our world is much more about adaptive behaviors, right? So these tools do not today adapt. They're batch learners. I spend a whole bunch of time and energy and money training it to learn a whole bunch of stuff, and then it's kind of fixed. I do a little bit of reinforcement to tune the way that it's allowed to respond. But if you interact with one of these and you go, well, that was just wrong, and it goes, oh yes, well, I won't make that mistake again. But you start a new session, it'll be wrong the same way again. Well, depending on random chance to some level, it doesn't update. It doesn't learn as it goes.
So that adaptation piece is really, I think, a super good point on that.
Well, mind you, but I can build an AI that a machine learning system that does adapt, right?
Yeah.
So it's a good point for that particular algorithm. It may not be a great point in general.
Right. Yeah, I'm kind of thinking of and I'll definitely be thinking about this after our conversation. I could just see, because I'm trying to think of like transcription, DNA and RNA and all of these things that are being made, these building blocks of life, and how those compare to building blocks of a program or a system or a software. Very interesting. Yeah. Then the parallels with viruses and things, and you can just go, oh, that.
and there's some fantastic work on AIs that are closer to viruses or responding, do learn on the fly, but they have very different, and they have very different applications, right? They don't show the level of complexity that we get out of an LLM so far, and we don't necessarily want them to either, right? So if you're going to build an artifact and put it in the world, do I really want it to learn maladaptive things or, suddenly not be reliable enough for me to support it? Someone's just bought this thing and suddenly it doesn't behave the way it's been promised to behave. So there's this really interesting mix of how does the commercial world interact.
Absolutely. Awesome, Michael. I know it's been an hour. I do have I have one topic. Can I ask? Do you mind?
Of course.
Do you have a couple more?
It's fun.
Okay, so a couple more minutes here, because I think this is a super, super important topic when it comes to robotics and humanoids. And as I'd mentioned to you, when I go out into the world and I see people working in certain jobs, and what is the future of work implications with robotics the more that it enters into society? So one of the things I think about often is just autonomous drivers and truck driver. I mean, there's so many companies out there that have fleets that are on the road already. And you think of how safe it will be when there are autonomous vehicles and people aren't looking at TikTok when they're driving.
Yep.
When you look at the future of work and labor and robots taking do you feel like it's going to be this taking of jobs? Because on one hand of the spectrum, we have people saying there's going to be massive unemployment and maybe a universal income. And then on the other hand, people will go, don't even mention that. It's just going to augment what people do and it's not going to take jobs. Where do you kind of land on that spectrum, or where do you believe things are going to go?
So from a practice perspective, from the sort of companies we work with, we really like the, augmented humanity, right? So what new things can we do that we couldn't do before? Or what gaps are we filling? What that ultimately means is we're focusing on companies that really matter, but it's part of a much larger trend. And there's no doubt that some tasks, and by and large, these are not jobs, these are tasks, will be, in some cases, taken from people. And there's going to be some economic dislocation for some people. Now, at the same time, this is, age old, new technologies coming through and changing the world. I don't see this happening incredibly quickly. One, we are entering an age where demographics mean that it's probably quite nice for many of us who are aging to be able to have the working population be helped with all of the manual work that otherwise needs to happen. So from a demographics perspective, that's useful.
Oh, yes.
Right. So
With an aging population, it's shifting. Yeah.
One of the reasons that China's so keen on robotics is they have a workforce situation, and they're pushing very hard to get more robots into the factories to make things work faster. These are still, a way away from major change, right? Look at self-driving. It's been something that's been promised for quite some time. We're starting to get it with Waymo and with a bunch of the truck driving companies. But even there, that's still early days. I'm not expecting an overnight shift from, where the people who are working in those areas are suddenly unable to continue. So it's are there job dislocations that will come out of robotics in the longer term? Absolutely, right? And it's a sad reality. Are there a segment of the robotics industry that is net positive, solves problems that we otherwise couldn't solve? Yes. Right. And so there's a balance. And as with any of these technologies, we will one way or another muddle through. I'm not convinced that we get to the need for the universal basic income from robotics in the near term. I'm not even convinced that we get there from the use of AI in the shorter term, because there's a subset of jobs that are wildly affected, but people are pretty cautious about this stuff, and it hasn't yet been proven to be as reliable as the forward thinkers are anticipating.
When you say short term, or near term, what how many years would you say that is for you?
5 to 10 years.
5 to 10.
Yeah, so maybe in 20 years we're in a completely different place. But it's really hard to forecast that sort of thing. And indeed, one of the things that Andrew Kay, who runs Silicon Valley Robotics, talks about how quickly different technologies actually emerge. How long did it take for the motor car? How long does it, so how long does it take for, even if we solve all the problems with humanoid robots, how long will it take to actually have them distributed? Distribution of innovation is a diffusion of innovation is not an overnight affair. So there's time to adapt. That said, I mean, I would absolutely counsel that people be aware of, what's new in robotics, what's practical today, where that might go, what's new in AI, what's practical today, and where that might go.
Awesome. All right. So as we end this, firstly, where can people find you if they wanted to reach out and know what you're up to? The second thing is, you can end with, what are you most excited about in the field of robotics? If you could choose one thing that jazzes you, what would it be?
All right. So I'm with the Robotics Hub. It's probably best to reach out. I post occasionally on LinkedIn. That's probably my most common, my most frequent social media location. So either reach out or follow me there. In terms of what I'm most excited about, look, I am very excited about this humanoid robotic space. I am very excited about solving some of these problems where at the moment there's not enough people to do the jobs, right? And in logistics, these jobs of picking up boxes and moving them around, not complicated, but people get injured a lot. And it's hard for the companies involved to maintain, or to recruit enough people to do those jobs. So I'm very excited about seeing the first true humanoid robots being used at scale in these sorts of scenarios. I'm very excited about this very pragmatic, let's solve one thing at a time and get it out there and make it happen. And then on the AI side, I think there's massive amounts of untapped opportunity around hybrid AI, right? So we're very focused on the neuro side, right? So deep learning derived algorithms. There's an awful lot of things from the symbolic AI, from being able to say, this thing relates to that thing, that become very valuable in reducing the propensity for things to confabulate and improving reliability and all those other pieces, right? So there's a large number of untapped technologies that we will see running on GPUs over the next 5, 10, 20 years.
Wonderful. Oh my gosh. So many exciting things ahead. So many more topics of conversations left unsaid, but hopefully in the future we'll be able to chat again. This has been super lovely. Thank you so much, Michael, for taking the time. We really appreciate it.
That's my pleasure, Eric. Thanks for the opportunity.
Cheers.